So a matrix is just a rectangular or square arrangement of numbers in rows and columns. So we're going to denote matrices with a capital letter. That's going to be like the name of it. Your numbers and variables in the matrix are called elements. Okay, so the elements of a matrix are just anything in the matrix. So what a matrix looks like, it just has these brackets, and you've got any amount of numbers or variables inside. Okay, so the dimensions of a matrix are given by rows, by columns. So you're going to look at the number of rows and then by the number of columns. Okay, and that's really important to get that down because when we get to multiplying matrices, that matters. Okay, so if I look down matrix A, I've got 4, -1, 5, 0, 6, 3. How many rows does it have? How many columns? So it is considered to be a 2 by 3 matrix. Okay, so for two matrices to be equal, their dimensions have to be the same and the elements of corresponding positions have to be the same. So think back to when you did in geometry like two parallel lines cut by a transversal and you had corresponding angles. Y'all remember that? So corresponding positions, still it means the same thing with matrices. Okay, so first row, first column should be equal to first row, first column in the second matrix. Okay. To add, you have to have the same dimensions. Okay. So you're going to just be adding or subtracting basic numbers in their corresponding positions. Okay. And you can only add or subtract if they have the same dimensions. So a 2 by 2 and a 2 by 3 is not possible. Okay. So a lot of this first part you can do in your head and you don't need to write it out like I write it out, but I'm going to do that just so that you can see. That way you're not making simple mistakes, okay? So corresponding positions, if I'm taking the first matrix and adding the second matrix, I'm going to take A and add it to E. Then I'm going to take B and F and add that together. I'm going to take C and G, add that together, and D and H, and add that together. So when you're adding corresponding positions, you're going to put that sum also in that same spot in the next matrix. Okay? So again, right here, I'm going to write out what we're adding, but after this first example, you should not have to write that out. Okay, we're doing basic addition. Okay, so if I'm looking at this, I've got 3, 0, -5, -1, -1, 4, 2, 0. I'm going to take 3 and add a -1. I'm going to write it. I know this is not mathematically how I ever accept it, but right now, since we're adding, I'm going to put it like this so you can see what you're adding. Okay, so we're adding 3 and -1. And then I'm going to take 0 and 4 and add that together. -5 and 2 and add that together. And then -1 and 0 will be added together. Okay, so -3 minus 1 gives me 2. 0 plus 4 will give me 4. -5 plus 2 will give me -3. And -1 plus 0 is going to give me -1. Very simple. Okay. So again, all you have to do is go straight. Oh, I don't know why there's a plus there. That shouldn't be a plus. That should be an equals. Sorry. I copied and pasted and then forgot to change it. So you can go straight to this final matrix. You do not have to show me this. Okay? So here, I've got negative 2, 3, 1, negative 1, 0, 4, 4, negative 1, and 6, negative 3. It doesn't work. Why does it not work? Alright, so we're going to put not possible because the dimensions are not the same. Y'all good with that? Okay. So then subtraction is going to be the same concept. You're just subtracting the corresponding positions. So again, we are going to write it out just so you can see it, this first example, and then we're going to go straight to the final matrix after this. But here we would take A minus E, and then we would take B minus F, C minus G, and D minus H. So be careful with your minus and negatives, okay? Usually people make minor mistakes with subtracting the negative. Y'all see it and you know it should be a plus, but you still don't consider that, okay? Sometimes when y'all are so worked up about a quiz or a test, y'all make those little bitty minor mistakes. This is where they start happening, okay? So if I'm looking at this one, what type of matrix is this? What are my dimensions? A 3 by 2, and what about the second one? 3 by 2. They're the same dimensions, so I can do my corresponding elements. So I'm going to take 7 and subtract negative 2. Again, I'm just going to write it out so you can see what's happening. I do understand that's a plus, but I don't want to confuse people. Then I'm going to take 4 minus 5. And then 0 minus 3, negative 2 minus negative 10, negative 1 minus negative 3, and 6 minus 1. Okay? So then, 7 plus 2 is going to give me 9. 4 minus 5 is going to give me negative 1. 0 minus 3 is going to give me negative 3. Negative 2 plus 10 would give me 8. Negative 1 plus 3 would give me 2. And 6 minus 1 would give me 5. Y'all good with that? Okay. Very simple. I know I'm going slow, but it's okay. I want to make sure y'all get that. Your scalar multiplication is just as easy. Okay? A scalar is basically just a number in front of your matrix, so it's just a real number. Think about if I gave you 2 times x plus 4. That 2 is a scalar. Okay? What would you do with that 2 in this example? Distribute. So that would give me 2x plus 8. So I multiply it by everything in parentheses. The same thing happens with scalar multiplication. You're going to take this number and you're going to multiply it by everything in your matrix. So you're doing k times A, k times B, k times C, and k times D. So basically distributing that number. So same thing, this middle part, I'm not going to require you to do that in your work. You should not have to do that in your work. We're just going to do it right now. Okay, so here I'm going to do negative 2 times 4. And then I'm going to do negative 2 times negative 1. Then I'm going to do negative 2 times 1 and negative 2 times 0. Negative 2 times 2 and negative 2 times 7. Okay, so what's my first row going to be? Negative 8, 2. Second row? negative 2, 0. Last row, negative 4, negative 14. Very simple. So now what happens if I have multi-step? Okay, I've got a negative 4 in front of this first matrix, and then I have minus the second matrix. Okay, what I'm going to do is multiply that negative 4 by every single element in that first matrix, copy it down, then I'm going to subtract my second matrix. Okay, so follow your order of operations. So negative 4 times 2 is going to give me negative 8. Negative 4 times negative 1. Negative 4 times negative 3. There's my first row. Negative 4 times negative 7. Negative 4 times 6. Negative 4 times 1. Negative 4 times negative 2. Negative 4 times 0. Negative 4 times negative 5. Fantastic. And then we're going to copy down the second matrix. And then we're going to subtract. Y'all good so far? Okay. Negative 8 minus 6 is going to give me 4 minus 0. 12 minus negative 2. Then 28 minus 12. Negative 24 minus negative 5. Negative 19. Negative 4 minus 4. Negative 8. 8 minus 7. 0 minus negative 8. 8. 20 minus negative 3. Alright, so this is going to sound super mundane, but type it in your calculator, because I promise you, you do not want to make a simple mistake with something like this. Okay? Save the mistakes for when you get to the bigger methods. Okay? So even though that sounds crazy, you can do your own basic addition and subtraction. Double check yourself, especially on a quiz or a test. It doesn't take that long to type it in your calculator. Okay? Just make sure you don't mess up your minus negatives. Okay? Alright. Now, if I have two equal matrices and I have to solve for x and y, I'm going to use my corresponding equal elements to solve for my x and y. If I'm looking at my first matrix, I've got my x in my first row, first column. So what is its corresponding element? 20. So I'm going to take 2x and set it equal to 20. Alright, divide by 2, x is equal to 10. Hopefully you can see that. Okay, then I'm going to look at where is my y. Okay. 30 equal to 5y. Y is equal to? Very simple. Okay, when it's already set equal for you, very simple. You just have to look, find the variable, set it equal to its corresponding element. Alright, now, sometimes it's not that simple though. Sometimes you got to do a little bit more. You got to simplify first. So this is where your order of operations really plays a role. I've got 3, then I have parentheses, and inside my parentheses are 2 matrices being added. Okay, so what am I going to do there? Yes, I'm going to take those 2 matrices and add them first. I am not going to distribute that 3 to everything. Could you? Yes, but I wouldn't. Okay, I would take those 2 matrices and combine them, and then I would multiply by the 3. Okay, so I'm going to have my 3. Now, when you're doing your own matrices, write as neat as possible. Y'all's are not going to be perfect. Mine are not perfect. Sometimes the spacing is too cramped. Sometimes it's not, it's too far. Just make it neat so I can follow you, okay? And so you can follow you and not guess what numbers are what. All right, so when I'm adding, I've got 5x plus 3. I'm just going to write that as is because they're not like terms. And then I've got negative 2 plus 7, and that's going to give me 5. I've got 6 plus a negative 5, so 6 minus 5, 1. And then negative 4 plus negative y is just going to be negative 4 minus y, or negative y minus 4. Okay, same thing. And then I'm going to copy down the rest equals negative 21, 15, 3, and negative 24. Now, I didn't say this earlier because I had the matrices down, but make sure you have it as brackets because our next lesson, we write it a different way, so make sure you've got the brackets there, because if you don't, it means something else, okay? All right, now we're going to take this 3 and we're going to multiply it. So pay attention when you've got an element that is actually a binomial, you're going to have to take that 3 and distribute it to both terms in that one element, okay? So for those of you who maybe miss details sometimes, I would circle any element that has a binomial so you know, hey, I got to do something with this. All right, you just have to multiply everything, but that's a mistake too. That's common. Okay, so 3 times 5x is going to give me 15x. 3 times 3 is going to give me 9. Then 3 times 5 is going to give me 15. 3 times 1 give me 3. And then again, I've got a binomial in this element. So what is 3 times negative 4 minus y going to give me? You're multiplying. So negative 12 minus 3y. Equals my negative 21, 15, 3, and negative 24. Okay, so I'm going to look for my x, 15x plus 9, and negative 21. I'm going to set that equal. How am I going to solve? Subtract the 9, so 15x is equal to, and then, and x is equal to. Very good. Alright, then I'm going to find my y. Negative 12 minus 3y will equal, so I'm going to add 12, and negative 3y will equal, divide by negative 3, and y equals 4. We good to move on? Are we good? Alright, so now, instead of just a number, I've got a variable with this 2. We're still going to treat that like scalar multiplication. Okay, we're still going to take this 2x and multiply it by every element in the matrix. So that's going to turn into what? What's my matrix going to be? Okay. And then copy down negative 6, negative 12, 12, and 3y. Alright, so I have an x in all 4 elements of my first matrix. Pick one. Okay, I'm going to pick the first one. So I'm going to set 2x equal to -6. Divide by 2, and x is equal to -3. Now I'll find my y. My y is second row, second column of my second matrix. So that is equivalent to 6x. So I've got 6x is equal to 3y. Yes, I'm going to take, I've already solved for my x. So I'm going to take that -3 and plug it in. So that gives me -18 is equal to 3y. So y is equal to y'all good with that? That's the really simple part. Okay? Now we're going to talk about multiplying the matrices instead of just scalar multiplication. Okay? So multiplication of matrices is defined only if the number of columns in the first matrix is equal to the number of rows in the second matrix. Okay? The product matrix will have the same number of rows as the first matrix and the same number of columns as the second. So all of that is a bunch of words. Okay? You're going to have row 1 by column 1. We're going to say 1 for the first matrix. Okay? And we're going to multiply that by, say, row 2, column 2. Only the subscripts are just matrix 1, matrix 2. Okay? Because our dimensions are row by column, right? So what all of this means is that your inside numbers, when you write your dimensions, the column and the row, so your inside numbers, have to be equivalent. They have to be the same. Okay? So if they're the same, then your product matrix will be your dimensions of your outside numbers. Okay? So if your two middle numbers are going to be the same, then your product matrix will have the first and the last. I have to visualize it like that instead of read all that. Okay? If you multiply the matrices or if you're looking and your dimensions are not the same, so the number of columns in the first matrix and the number of rows in the second matrix are not the same, it's undefined. Okay? With addition, we say it's not possible. With addition and subtraction. With multiplication, we say it's undefined. If you write not possible, like if you flip-flop those, yes, you're losing credit. Okay? So multiplication is undefined. Make sure you know the difference. Okay? So matrix multiplication is not the same as scalar multiplication, and with matrix multiplication, your order really matters. Okay? I'm going to emphasize that in another lesson, but for right now, we're good. Everything's set up to where it should be in these notes. Okay? So what we're looking at is we're just going to get this pattern down. Okay? What I talked up here, we're going to just make sure we understand that. So if I take a 2 by 3 and a 3 by 4, can I multiply that? Yes, because my 3 and my 3 on the inside is good. So that's going to give me a 2 by 4 matrix. Okay? So if I do a 7 by 1 and a 1 by 2, can I multiply that? Yes, it would give me a 7 by 2. What about a 3 by 3 and a 2 by 3? Nope, it's undefined. What about a 4 by 3 and a 3 by 5? It's going to give me a 4 by 5. So y'all understand what I meant up here now? Okay. Okay, so we're going to state if the product is defined, and if so, we're going to give the dimensions of the product matrix, and we're going to multiply it. No, we're not going to multiply it. We're going to set it up, and we're going to say if it's defined or not. Sorry, I'm ahead of myself. So AB, I'm taking my matrix A, 2, negative 1, 3, 4. And I'm multiplying it by 3, negative 9, 2, 5, 7, negative 6. Okay, so I need to write down my dimensions. My first matrix is what? 2 by 2. And my second matrix is a 2 by 3. Can I multiply that? Yes. What would it be? A 2 by 3 matrix. Okay, what about B times A? So now B is coming first. 3, negative 9, 2, 5, 7, negative 6. And I'm multiplying that by my 2, negative 1, 3, 4. So now in the different order, I've got a 2 by 3 multiplied by a 2 by 2. That's undefined. So this is why your order of your matrices matter. Now good? Okay. So multiplying your matrices. You're going to multiply the elements in the row of the first matrix by the elements in the columns of your second matrix. So you're doing row by column, okay? I am going to show you with numbers on the outside so you can visualize what you're doing. It gets easier once you get the pattern down, okay? You're going to take those products and add them, okay? What I mean by that, let's write it first. We're going to find 1, 4, 3, negative 2 times 5, negative 7, 9, 6. Okay. I'm going to put little numbers on the outside, being that this is my first row and second row, and this is my first column and second column. Okay, and then I'm going to do it over here. This is my first row, first column, second column. So when I multiply, I need first row, first column, right? So what I'm going to do is I'm going to multiply first row, first column. Okay? To get the number for first row, first column. But what I'm going to do, you see how you have two numbers? You're going to multiply first number times first number. So 1 times 5. And I'm going to add second number times second number. 4 times 9. Okay? So first row, first column, first number, plus second number, second number. Okay? So then I need first row, second column. So I'm going to multiply first row, second column. Okay? So I'm going to take first number, so 1 times negative 7, plus second number, 4 times 6. Y'all follow that? Somewhat? Alright, now I need second row, first column. So what am I going to multiply? Second row, first column. So if you see the position and you say it to yourself, you're telling yourself what you're multiplying. Okay? So then I'm going to multiply 3 times 5 plus negative 2 times 9. Because you do first and first, second and second. Okay? then what do you think I'm multiplying for this last element? Row 2, column 2. So I'm going to take 3 and multiply it by what? Plus -2 times 6. If you want to write this until you get the hang of it, do it. Okay? This is where mistakes are made, and I can't backtrack. Okay? If you write this, I can, but I can't backtrack typically when we do matrix operations. Okay? So, 1 times 5 is 5. 4 times 9, 36. 5 plus 36. Remember that you do not have to do this mental math. You can type this exactly as you see it in your calculator. Okay? You can do whatever you need to in your calculator. Just don't make minor mistakes with your negatives. Okay? So here I've got a -7. If you need to even write it right here. -7 plus 4 times 6. 24. What's -7 plus 24? So then 3 times 5 is 15. I got -2 times 9, so that's a -18. Gives you -3. Then I've got a -21 minus 12. That's going to give me follow me on that? Do we have questions on how we got those numbers? Okay. Alright, so now we're going to multiply B times A. So 5, -7, 9, 6 times 1, 4, 3, -2. Alright, what I'm going to do, I'm not going to write it out like I did here. I'm going to do this. Okay? You should be able to follow me on that part. Okay? So, I need first row, first column. So I'm going to multiply first row, first column. 5 times 1 is 5. I'm going to put a plus so you understand I'm adding, because there's the next lesson where you're subtracting. There's a lot of flip-flopping from one lesson to the next, so that's why it's a lot with matrices. Okay? -7 times 3 is going to give me -21. Okay? Then I'm going to take first row times second column. 5 times 4 is going to give me 20 plus -7 times -2. Alright, then we're going to do what? So 9 times 1 is 9, plus 6 times 3 will give me 18. We good? Okay. So then second row, second column, 9 times 4, plus 6 times -2, -12. Obviously, if you know that that's 36 minus 12, write it like that. I'm just writing the plus so you understand you're adding, okay? Alright, so 5 minus 21 is going to give me -16. 20 plus 14, 9 plus 18, 36 minus 12. good with that? Okay. All right, now I didn't emphasize writing down those dimensions because I knew they were both 2 by 2. You can look at that and you can tell, okay? So when they're not, I encourage you to do your dimensions underneath. So that's a 2 by 2, and then this is a 2 by 3. I want to double check. Yes, it's going to work. So that means I'm going to have a 2 by 3 product matrix, okay? Why is that important? That helps me visualize what I'm doing, okay? I'm still going to do my middle step because I want you seeing what you're doing. I'm taking first row, first column. 3 times 5 is 15, plus negative 5 times 8 is a negative 40. First row, second column, 3 times 1, 3, plus negative 5 and negative 4, give me 20. Then I'm taking first row, third column, okay, 3 times negative 3, plus negative 5 times 9, negative 5 times 9, negative 45. We good with that? Okay. So then now, second row, first column, 2 times 5 is 10, plus 7 times 8 gives me 56. 2 and 7, so second row, second column, 2 times 1, 7 times negative 4. And then second row, third column will give me negative 6 plus 63. Okay, so it's up to you when you have that negative for your second product, it's up to you if you want to write it this way or this way. Okay? All right. $15 minus 40. 3 plus 20. Negative 9 minus 45. 10 plus 56. 2 minus 28. Negative 6 plus 63. Y'all good with that? Okay. Okay, now we've got a multi-step. Okay? You have to set up your matrices before you do anything. If you add B and C in your head and do A times whatever you got, you will get points taken off. Your very first step will be to do what I've been doing. Set up your matrices. Okay? So I'm going to have A, then parentheses, and I'm adding B plus C. So regardless of what your problem is telling you, I have to see this. Okay, this first step. Then think about your order of operations. What are you going to do? You're going to add your matrices because that's what's in parentheses. Okay? So I'm going to copy down that first matrix. Please make sure your stuff is neat. I'm going to add -3 plus 1, 0 plus 4, 1 plus -3, -2 plus -1, Alright, it comes to multiplying. I know they're different dimensions, so I need to think about it. This is a what? By 2 by 2. So I know my product is going to be a 3 by 2. Okay. So first row, first column. So I'm going to have -8 and a -6. Then first row, second column, 4 and 4 gives me 16. 3 and -3 gives me -9. Then I'm going to do second row, first column. -1 and -2 is 2. -2 and -2. So 2 plus 4 there. Then I've got -1, -2 multiplied by 4, -3. So -1 and 4 is going to give me a -4 plus 6. Y'all good? Okay. Then third row, first column, 2 and -2 gives me -4 plus 0. And then third row, second column, 8 plus 0. -8 minus 6. 16 minus 9. 2 plus 4. -4 plus 6. Then -4 and 8. Now, I'm going to be lenient and you don't have to show me this, but I recommend it. Okay? I would say, especially on a quiz or a test, it doesn't hurt to do that. Okay? Okay. We're doing AB plus AC. Okay, so we've got 4, 3, -1, -2, 2, 0, times -3, 0, 1, -2, plus our A matrix again, times our C matrix. We just did a 3 by 2 times a 2 by 2, so we know it's possible. So we're going to multiply. First row, first column. What's it going to give me? Very good. Negative 12 plus 3. First row, second column. Second row, second row, first column. 3 minus 2. Second row, second column. 0 plus 4. Third row, first column. And then third row, second column. So once you get the pattern down, it really doesn't take that long. Okay, and then I'm just going to go ahead and multiply and then simplify. Okay. So now I'm going to do the same thing. First row, first column. First row, second column. Minus 3. Second row, first column. Second row, second column. Third row, first column. Third row, second column. Y'all feel okay multiplying? Okay. I'm looking down instead of looking at y'all, so I want to make sure y'all are okay. Alright. Negative 12 plus 3. Negative 9. 0 minus 6. Negative 6. 3 minus 2. 0 plus 4. Y'all's participation is fantastic. Negative 6 plus 0. And all of them still don't speak. Alright. 4 minus 9. There we go. Negative 1 plus 6. Negative 4 plus 2. 2 plus 0. 8 plus 0. Good job. Okay. Now we add. Negative 9 and negative 5 is going to give me negative 14. Negative 6 plus 13. 1 plus 5. 4 minus 2. Negative 6 plus 2. 0 plus 8. Alright, we good? Now we're going to do a 3 by 3 times the 3 by 3. Okay? Okay, so you know how we did first and first, second and second? So now we're throwing in third and third. Okay? So still doing first row, first column. So 3 and 2 is going to give me 6. Negative 1 and 1 gives me negative 1. Negative 5 and 5 gives me negative 25. Okay, first row, second column. 3 and 4 is going to give me negative 1 and 7. And then negative 5, negative 1. First row, third column. Plus. Minus. We good? Did we say no? Okay. All right. Second row, first column. Oh, negative 4. You're on second column. Second row, first column.
Oh.
Negative 2 and 2. Then plus 4. Plus. Okay. All right, now's your time to shine. What is it? Oh.
Negative 8 plus, yeah, I'm sure. Plus 28 plus 2.
Minus 1. Okay, look. First and first.
Oh, I see what I did.
Second and second.
I see what I did wrong.
See how easy it is to start making mistakes? The colors make it happen. Okay. Second row, third column. Use your fingers. All right. Negative 2 times negative 3. Very good. Okay. Last row, first column. Yes. Last row, second column. There you go, you redeemed yourself. All right. All right, use your calculators if it's going to be a problem.
Yeah.
6 minus 1 minus 25. All right, 12 minus 7 plus 5. $37 is what y'all said? Negative 7. And then? The good news is when you're doing your homework, quiz, and test, you don't have people in your ear telling you faster than what you can process, okay? However, you don't have all the time in the world when it comes to your test, so you're gonna have to be able to get it down. Now, do y'all understand the concept? Do we have questions on the method?
not